Hey guys, it's Miss Johnson, and I'm here to bring you the second part of Chapter 5.1 notes. Today we're going to talk more about the simulation side of things. So yesterday we talked about just probability and randomness in general and how events are random, and the more trials we repeat, the closer we get to the true probability of something. But today we're going to actually talk more about that simulation piece, because that simulation piece is what's going to be important in our upcoming experiments. So Simulation is the imitation of chance behavior based on a model that accurately reflects the situation. So the simulation process, you're going to describe how to use a chance device to imitate one trial or repetition of a simulation. You're going to tell what you record at the end of each trial. So you're going to use a computer generator or like a random number generator on your calculator or something, depending on what it is. You're going to use some device to randomly simulate a trial of a certain experiment. You're going to do that many, many times, perform many trials of the experiment, and then you're going to use the results of your simulation to answer the question of interest. So we're modeling an experiment of what could happen, and we're doing it over and over and over and over and over again to show what we think the true population probability would be. All right. So let's take a look at an example. In this first example, it says, in an attempt to increase sales, a breakfast cereal company decides to offer a NASCAR promotion. Each box of cereal will contain a collectible card featuring one of the following NASCAR drivers: Joey Logano, Kevin Harvick, Chase Elliott, Danica Patrick, or Jimmie Johnson. The company claims that each of the 5 cards is equally likely to appear in any box of cereal. A NASCAR fan decides to keep buying boxes of cereal until she has all 5 drivers' cards. She is surprised when it takes her 23 boxes to get a full set of cards. Does this outcome provide convincing evidence that the 5 cards are not equally likely? To help answer this question, we want to perform a simulation to estimate the probability that it will take 23 or more boxes to get a full set of 5 NASCAR cards. So here's what the company is claiming. The company is claiming that, each card is equally likely. Each card is equally likely to occur in any of the boxes of cereal. And the person who's buying the cereal, the NASCAR fan who wants to collect all the cards, says, no, it's absolutely not, because it took me 23 boxes of cereals to get all 5 cards. That doesn't make sense. That's not saying that it's equally likely. So we perform a simulation of this trial and see if 23 boxes is too many. If it's out of the ordinary for you to need 23 boxes of cereal to get all 5 cards. So the question becomes, how do we do that? Well, if we use a random number generator on our calculator to perform one trial, what would we do here? What we would need to do is we'd need to set up a numeric system for each thing. So the first thing I'm going to do, there's 5 drivers. I'm going to give each driver a number. So in part A, I'm going to say let 1 equal, and I'm just going to go in order of the drivers. Joey Logano. Sorry, my handwriting is not very nice today. Joey Logano. So then 2 is going to be Kevin Harvick. So then 3 is going to be Chase Elliott. 4, there's 2 T's there. Sorry, Chase. 4 is going to be Danica Patrick. And 5 is going to be the last one, Jimmie Johnson. Okay, so that's how I'm going to assign the numbers, and then I'm going to use a random integer generator. So use random integer generator from 1 to 5 to simulate buying a box of cereal. I can spell, I swear, a box of cereal and what card I will get. Okay, I repeat this random number until I get all 5 cards. Repeat the generator until you get all 5 cards. Okay. And then record the number of boxes I had to buy. To get all 5. Okay. So now in part B shows the number of cereal boxes it took to get all 5 drivers' cards over 50 trials. So what they did is they repeated that experiment 50 times, okay? So explain what what the dot at box number 20 says. So in part B, they're looking at this dot right here, okay? That dot at number 20 tells me that it took 20 boxes of cereal to get all 5 drivers' cards. Okay. And then look at the next part, C. It says use the results of the simulation to estimate the probability that it will take 23 or more boxes to get a full set of cards. Does this outcome provide convincing evidence that 5 cards is not equally likely? So if I take a look at part C, I'm looking at how many times in this dot plot did I get above 23? Here's 23 right here. If you look at all of the dots are below 23. Okay, so there are no times that I got above 23 boxes out of the 50. 0. There are literally 0 times out of 50 that I got above 23 boxes. Okay, so the probability of getting greater than 23 boxes was 0 out of 50, or in other words, 0. Okay, so that tells you there's a 0% chance of needing to buy, or that it would take, of it taking 23 boxes or more to get all 5 cards. So what this person was saying here is that there's no way that the cards are all equally likely in the box. There's no way. It took me 23 boxes to get all 5 cards. And you're telling me that there's a 0% chance that if the cards were equally likely, that I'd have to buy 23 boxes. So since it's so unlikely for me to need to buy 23 boxes, that tells me that there's no way that it's really convincing that the cards are not equally likely to appear in each box. So that's what this result is showing me. This result is showing me, I should say this result provides convincing evidence that there is not an I can spell, you guys, equally likely chance of getting all 5 cards in the box. Chance, not change, chance of getting, I should say getting each driver's card in a box. Okay, so just one more time, I'm going to recap that result one more time. because it was so unlikely for us to need to buy 23 boxes. In our simulation of 50 trials, no result was greater than 23 or was 23 or above. No result. That happened 0 times. So in our simulation of 5 trials or of 50 trials, where each of the 5 drivers was equally likely, okay, because we did a random number generator of 1 through 5, there was an equally likely chance of getting numbers 1 through 5. In our simulation of 50 trials, 0 times did we need 23 boxes or more. So since in actual real life, this person needed 23 boxes to get all 5 cards, that provides us enough convincing evidence that the cards aren't equally likely in the boxes, okay? We're not equally likely to get each card in a box because it's such a low probability. In our case, it was 0% chance that we would need 23 boxes or more. So that makes it an extreme value. That makes it outside of the realm. That's really, really far away from what we would expect to happen. So since we don't expect it to happen, since it's such an unlikely probability, we cannot say that those cards are equally likely in the box, in the cereal boxes. Okay, it's a very confusing concept. Simulation is tricky. It's a tricky thing for us to think about. But basically what we're looking for is the extremes here. We're looking for things to be really, really, really unlikely. If they're really, really, really unlikely, then that tells us that the claim from whatever company we're looking at is maybe not correct. The claim is not accurate. Okay, and that's what we're going to start to look for, and that's what we're going to start to test when we get into later chapters of the book. All right, so that's the idea of simulation. Thanks for listening. Thanks for tuning in, and I will catch you guys next time.